metal hydroxide catalyst will produce pentaerythritol. Next. Pentaerythritol can be seen as white, crystalline, and odorless compound. It has the boiling point of 276 degrees C, and it is soluble in water at 25 degrees C, and soluble in ethanol and ethylene glycol. It is flammable when contact with heat or flame, and it can cause irritation to the eyes and respiratory system. Next. This is some of the application of pentaerythritol. Firstly, pentaerythritol is used to produce alkyd paint by esterification of pentaerythritol and polybasic acid, which have been modified by oil and fatty acids. Next, synthetic resins is formed by reaction of pentaerythritol with acrolein and glutaldehyde and various aldehyde. And next, pentaerythritol is used as flame retardant. When exposed to high temperatures, this coating will produce a solid and non-combustible residue which serves to protect the substrate from fire. And next, pentaerythritol tetanitrate is one of the derivative of pentaerythritol. It used to make explosive material. And lastly, pentaerythritol ester of fatty acid is used as lubricants for steam and automobile engine. Next.
So now I will continue for the market survey and outlook. Next. So as you all can see, these graphs show that the global demand for pentaerythritol is estimated to reach 781.7 kilotons by the year of 2020. And the market demand for Asia Pacific is expected to increase from 230,000 metric tons per year in 2030 to 378,000 metric tons per year in 2020. And around 39% of global pentaerythritol was used in paints and also coating industry. And due to the increasing construction activity and also positive outlook of automotive industry, the pentaerythritol market in Asia Pacific is growing rapidly. Next. So from the export data, we can see that the production amount of pentaerythritol in China is key, as China is one of the main suppliers for the global demand. According to the import amount of Southeast Asia countries, Malaysia can take this opportunity to involve in this market by export this pentaerythritol to Southeast Asia countries. Next. Next. So this table shows the suppliers for pentaerythritol around the world. And the production capacity for 2011 and also 2020 are estimated by using CAGR and also annual growth rate. Next. So these two graphs show the market price for pentaerythritol in China. And the latest market price for pentaerythritol in China is around 1,700 USD dollar per metric ton. Next. So this chart shows that how we estimate the capacity of our plant. We narrow down the scope of our investigation from global demand to Asia Pacific demand and finally to Southeast Asia demand. And at the end, we decided to set our capacity to be 20,000 metric tons per year for local demand and also export to Southeast Asia countries and other Asian countries. Next.
Okay, for site selection, we consider at Klang Selangor, Tanjung Lansak Johor, and Sarkis Sarawak. Next. So we select Tanjung Lansak Johor as our chemical plant. Next. This is because of the bigger land area availability for future land expansion. And then the raw material are easily obtained from nearby areas at Johor, Selangor, and Singapore. And the water electricity tariff are affordable. The distance from target company are nearest, like Seamaster, Musashi Paint, Sdn Bhd, and Sherwin-Williams, Sdn Bhd, and the cheaper land price for large land availability. The incentive offered by the Johor state government are attractive, like 100% exceptions of tax. The next one is there are skill and semi-skill level from UTM, UTHM, and others. And then the port availability are near to export the product for other countries. Next. So this is the site specification for our plant. The land area available are 1,096.2 hectare, and the land price is 12 ringgit per square feet. The utilities with the water supply from SAJ and the electricity from TMB. and the fuel supply from Petronas Supply Center due to the pipe run through the southern regions of Johor, and the facilities. This is the facilities and infrastructure, and the labor, and also the raw material supply for formaldehyde, acetaldehyde, and sodium hydroxide. And this is the distance from the seaport to our plant.
So now I will explain on the process selection. So based on our reading through article and through some research paper and patent, we have found that there are 4 types of reaction pathway, which uses same raw material, same product, and different substance involved and different side product form. And for the first reaction, the substance involved is sodium hydroxide as catalyst, and the side product form is sodium formate. And for the second reaction is uses calcium hydroxide as the catalyst, and the sulfuric for the second reaction, calcium hydroxide as the catalyst, and the side product form is calcium formate. And for the third reaction is the calcium hydroxide as the catalyst in addition with sulfuric acid and methanol, and the side product form is calcium sulfate and methyl formate. And the fourth reaction is using catalyst calcium hydroxide in addition with sodium carbonate and methanol. Side product form is calcium carbonate and sodium formate. And these are the calculation for economic potential and gross profit. The calculation must consider the overall reaction of reaction. And the calculation is done by multiplying the mass ratio of each substance with the current price of the each substance. And the gross profit for the reaction mean is ringgit Malaysia 2.99 per kg pentaerythritol. And for the reaction 2, the gross profit in ringgit Malaysia 3.37 per kg pentaerythritol. And for reaction 3, the gross profit ringgit Malaysia 2.99 per kg pentaerythritol. And for reaction 4, the gross profit is ringgit Malaysia 2.86 per kg pentaerythritol. And the gross profit summary, pathway 2 give the highest gross profit in 3.37 per kg pentaerythritol. So the comparison for each pathway 3 and 4 is less favorable because it requires many additional process and equipment, which is very costly. And for the pathway 2 is most favorable because calcium hydroxide is the catalyst, is very hard to get. And pathway 1 is most favorable because it is high yield and easy to remove the sodium ion. At the same time, the catalyst supply is very easy to get. So how we are going to select our process is by considering several criteria. For the gross profit, pathway 2 give the best score. For the side product, all pathway has give the side reaction and side product. And for operating condition, pathway 1 give the best score. Environmental effect, pathway 1, 2, 4 give the best score. And for the yield, pathway 1 give the best score. So in total, the best score belongs to pathway 1 and pathway 2 with 0.76. So how we are going to select it? We are going to consider the temperature. Temperature above 40 degrees C may cause this side reaction to occur. So as you can see from the pathway 1 operating condition, at that temperature, the reaction of Canazora reaction is very dominant. So in conclusion, we choose pathway 1 as our process selection.
Synthesis of process flow sheet. Next. Step 1, eliminate difference in molecular types. Based on our literature survey, there are 4 reaction pathways that are available for the production of pentaerythritol. So we choose reaction pathway 1 because it has low temperature reaction and sodium format easier to be separate from pentaerythritol, and less equipment will be used compared to other reaction. Next.
So now I'll explain on the step 2. As you can see from the figure shows the flow sheet for alternative 1. All the product formed from this flow sheet are being discharged to the surrounding and for storage, especially for the pentaerythritol. And focus on the stream formaldehyde. In flow sheet 2, stream formaldehyde is being recycled and mixed together with the aqueous formaldehyde. However, this alternative is not really favorable because it requires high cost and contains some impurities that may affect the reaction in the reactor. So how we are going to select which alternative is the best is by considering these 2 heuristics. Heuristic 2 says use an excess of 1 chemical reactant in a reaction operation to consume completely available chemical. So as alternative 1 and alternative 2 says, 25 of aqueous formaldehyde is being fed to the reactor to ensure fully use of acetaldehyde. And for heuristic 3, When nearly pure product is formed, eliminate the inert species. So this heuristic comply with alternative 1 as alternative 1 has no recycled formaldehyde is being introduced because contains some impurities, and this may affect the purity of the final product. As a conclusion, alternative 1 is being selected because it comply with heuristic 2 and heuristic 3. So the mess in and mess out for alternative 1 is same.
Okay, for step 3, we eliminate the difference in composition. So we eliminate the separation at formaldehyde and water, and then we also separate the sodium formate and pentaerythritol in aqueous solution for alternative 1. Next. For alternative 2, we recycle back the sodium formate and pentaerythritol in aqueous solution into the first separation, and then we also we recycle back the the formaldehyde into the mixer. Next. So both of the alternative, we choose alternative 1 because it has less equipment, so less budget and more economical. And the heuristic used to verify the selection are heuristic 2, 6, 12, and 20. Next.
So now I will explain on step 4. As you can see from the figure, they have 6 changes of temperature change and 2 pressure change. To eliminate temperature change, we use boiler, heater, or cooler. And to eliminate the pressure change, we use pump or turbine. So these are the justification of the operating condition. For mixing process at 35 degrees C is to prevent any appreciable loss of acetaldehyde. And for reaction process at 35 degrees C is to achieve 100% conversion and to avoid start reaction and other undesired products to be formed. And neutralization process at 35 degrees Celsius is because we want to obtain proper neutralization process and to gain small amount of impurities. And for the evaporator, the temperature is 1 to 0 degrees C to allow water and formaldehyde to vaporize. And for the 100 degrees C is because we want to obtain the good ratio of liquid before entering the crystallizer. For crystallization, the temperature of crystallization at 40 degrees C because we want to gain the best crystal in terms of amount. And the pressure under vacuum is to produce a viscous slurry of pentaerythritol. And the centrifugal filter at 30 degrees C is to avoid overheating. And the dryer at 1 to 0 degrees C is to allow to vaporize the water within the crystal.
Step 5, task integration. For this process flow diagram, there is a total 15 equipments that being used in this production. Next. This is the functionality for each equipment. So the first equipment is pump. Pump is used to increase the pressure of the liquid stream. Next is heater and cooler is used to heat up and cool down the stream involved in the pentaerythritol production. Mixer is used to allow mixing of formaldehyde, acetaldehyde, and sodium hydroxide before being fed into the reactor. Reactor is used for the reaction of aldehyde condensation and cross-Cannizzaro reaction to occur simultaneously at 35 degrees C and 1 atm. Neutralizer tank is used to neutralize the excess alkali by reducing the pH of the solution at 35 degrees C and 1 atm. Turbine is used to reduce the pressure of the liquid stream. Evaporator is used to separate pentaerythritol and sodium formate from formaldehyde at 120 degrees C and 2 atm. Crystallizer is used to form a solid of pentaerythritol and separate it from the other components at 40 degrees C and 0.6 atm. To separate crystallized pentaerythritol from the mixture slurry at 30 degrees C and 1 atm, centrifuges is being used. Lastly, a dryer is used to separate crystallized pentaerythritol from water to obtain high purity product at 120 degrees C and 1 atm. Next.
So now, so now I will continue for the manual mass and energy balances. Next. Before the mass balance calculation, some specifications are made. Our plant design is specified on a basic production of 20,000 metric tons per year, and our plant operates for 320 days per year, 24 hours per day. Next. For overall mass balance, there are total 4 input streams and also 4 output streams. The input stream included the aqueous sodium hydroxide, aqueous formaldehyde, aqueous acetaldehyde, and also aqueous formic acid. And the first output stream will be from the evaporator, The second output stream will be from the centrifugal, and the third and fourth output stream will be from the dryer. And after the calculation, the mass input is equal to the mass output. Next. So for the mixer, acetaldehyde and sodium hydroxide and formaldehyde is fit into the mixer in the ratio of 5 to 1 to 1.2. 25 weight percent of aqueous formaldehyde, 99 weight percent of aqueous acetaldehyde, and 16 weight percent of aqueous sodium hydroxide are required. And this table summarizes the mass balance for the mixer. Next. This is the overall chemical equation for our production of pentaerythritol, and the conversion we assume at 100% based on acetaldehyde. And this table also summarizes the mass balance for the reactor. Next. So for neutralization tank, formic acid is added to remove the excess sodium hydroxide, and the conversion we also assume to be 100%. And this table is the summary for the mass balance for the neutralization tank. Next. So for the evaporator, in this unit operation, water and excess formaldehyde is removed from the solution, and the specific gravities of outgoing slurry, pentaerythritol, and also sodium format are used in the calculation for the mass balance for evaporator. Next. So for the crystallization, the yield of the pentaerythritol crystallized is assumed at around 90%, where the other 10% remain in the solution form. And this table shows the summarize of mass balance for crystallizer. And the next one will be the centrifugal filter. And the purpose of doing this is to separate the solid pentaerythritol from the solution. And the moisture content loss in solid pentaerythritol is assumed at 6%. And the final process will be the drying process, where water is evaporated in the dryer. And this table is to summarize for the mass balance for dryer. So for energy balance calculation, heat of formation, heat of vaporization, and also centrifugal heat are included. So this table shows the input stream enthalpy and also output stream enthalpy for every unit operation involved in our process. So next, I will move to the simulation part. Next. So this diagram is the simulation flow sheet for our process generated through the Aspen Plus application. And this is the equation we use to calculate the error between manual calculation and also simulated value. Next. So from the table, only one stream, which is stream 21, has error more than 15% due to the centrifugal separation. This is because the assumption made for solid separation through centrifugal filter are based on literature review, whereas Aspen simulate the separation differently. So based on the literature review, only water with solid pentaerythritol are separated from the solution. But in Aspen, other than water, some amount of solid sodium format and also pentaerythritol solution are separated together too. So for energy balance, so actually energy balance is same as mass balance. Only stream 21 has error more than 50% due to the huge difference between the manual mass balance and also simulated mass balance. Because the error is around 83%, and this is the main cause for the huge error of energy balance in stream 21. So move to the innovation part. So for the innovation, we have two. So the first one will be the reaction temperature, where our reaction temperature is below 40 degrees Celsius. The purpose of doing this is to minimize the Cannizzaro reaction of formaldehyde, which will produce sodium format and also methanol. So the second one will be the evaporator. Instead of using distillation column, we use short tube vertical evaporator. So there are some advantages of using this type of evaporator. For example, high heat transfer coefficient, easy mechanical distilling, relatively inexpensive, can perform mechanical cleaning, and lastly, crystalline products can be removed using the agitator. So that's all for our presentation. Thank you for your time.
Okay, thank you very much. Wah, betul-betul 20 minit lah. Well done. Okay, guys, thank you. Okay, now I open to the panels. Dr. Nur Shiki, Dr. Hashim, Dr. Sahrudin. Bolehlah tanya. Siapa tanya dulu? Dr. Nur Shiki tanya dulu.
Okay, boleh tanya sikit. Saya nak terus jump pergi ke ni PhD je.
Okay, boleh. Teruskan.
Okay, so untuk yang saya nak tanya first kali, nak tengok dekat evaporator you. Evaporator. E102. E102. So kalau based on yang you hantar dekat kita ni, okay. For stream 12, Stream mana evaporator? Mana evaporator? You stream source kan? Ni.
Ni
Ni evaporator. Ni evaporator kan?
Yes.
So you punya flowsheet tu 2 ATM ke 1 ATM?
2 ATM Doktor.
2 ATM?
Dia
Ni
masuk
kat sini tu ada 1 ATM 100 degree C. Actually your evaporator operate at what pressure?
Inlet is 120 degree C to ATM. Outlet, both outlet is 100 degree C and 1 ATM.
You check balik dekat you punya apa ni sunrise table tu.
Alright. Okay.
Okay, tu you check balik. Lepas tu saya nak tanya lagi satu. Ni boleh lagi teruskan terus
Terus je tanya, tak apa.
Okey, teruskan Okey, lagi satu function E106. 106.
106.
Okey, saya nak tanya kenapa kita tak boleh filter pada 40 degree C?
A16.
E106. E106. Mana E106 you
You want sick tak ada?
Dekat you punya. Yang you punya ada? Dekat filter. Mana filter you?
Oh, this one, centrifugal filter. Yes. 3102.
Okey.
Kenapa tak boleh this one?
Tadi ini awak ada 40 degree C.
Yes.
Stream 17 you ada 40 degree C. And then you buat apa? You E105 tu. Okey. Kenapa you tak boleh filter terus pada 1 ATM 40 degree C? You must reduce the temperature to 30 degree C. Itu soalan saya.
Sebab centrifugal filter ni dia punya working principle kan dia akan berputar, which is when dia spinning it will generate heat. So bila dia generate heat due to high speed, so dia akan ada satu temperature yang tinggi lah. That's why we want to use operating condition as low as possible to avoid overheating.
Macam mana you tahu 30 degree C okay? Apa you justification dia? You reduce from 40 to 30 degree C.
Sebab salah satunya 30 degree C itu kan dia berdekatan dengan room temperature. So ada ada research mengatakan to less usage of power. So, sebab kita tak perlu nak tukar dia kepada temperature lain sebab yang 30 degree C tu dah room temperature kan. So ada room temperature tu the best operating condition to filter the crystal form. Yes.
Okay, it's okay. So kenapa nak pilih centrifuge? Ada any type of filter. Kenapa you nak dealing with the filter yang ada you kata dia boleh raise your temperature and so on. Kenapa tak use other filter yang tak involve heat dan sebagainya?
Kita pada solid tu supaya dia tak jadi macam lagi banyak liquid lagi banyak pentaerythritol in liquid form.
Apa?
Sebab kita nak bagi pentaerythritol tu dia keluar daripada in liquid form banyak. Sebab kita nak in solid form.
Yelah, the function of filter memanglah kita nak separatekan liquid and solid. So why you want to use centrifugal? So itu soalan saya. And so what happened to your stream 19? Di mana? Very 19 tu very large amount of ada banyak kat situ. So kenapa you stop stream 19 without recycling and so on?
Anyone to answer? Kalau tak saya answer.
Sebab kita lagi fokus pada in solid form.
Lagi satu doktor.
Sebab kita pakai sebab kita pun pakai centrifuge pun sebab kita nak kan centrifuge dia akan solid form tu dia akan turun.
Saya tak nak dengar yang centrifuge tu. Saya nak dengar yang stream 19 ni. Pergi mana? 19 awak ni pergi mana?
Stream 19
Ha?
kami discharge sebab
Ha?
kami discharge sebab kalau kami nak buat treatment, nak separate, it requires any additional equipment. So addition equipment tu kan dia memerlukan kos
Okay,
yang
okay, no. Okay, stop. So tak apa. So you pergi tengok stream 19. Apa dia punya content stream 19 ni?
Oh, dia ada sodium formate.
Mother liquor, the process of crystallization. You can recycle to the another crystallization process. Okay?
Tapi doktor dia ada sodium formate.
It's a mother liquor. It's not unwanted compound apa semua. This is a base, mother liquor base. So maknanya you boleh recycle to ataupun you put one crystallizer untuk ni crystallizekan lagi stream tu.
Oh, so doktor
nak pergi buat
maksud dia ada recovery untuk komponen dalam itu stream 19 lah.
But you nampak crystallizer, what is the function of crystallizer? Nak crystallize, and then bila you crystallize, you got some solid, and the rest is a mother liquor. Still can crystallize. Maybe you can put another crystallizer. Bukan you buang stream 19 without any process.
Okay, sure, doctor. Because you mix out and you add another crystallizer to crystallize. The stream 19.
Okay. Itu je Zaki.
Okay, yang lain ada soalan? Dr. Sordin, Dr. Hashim?
Saya nak tanya PDF juga. Boleh?
Boleh.
Saya nak share screen boleh?
Boleh.
Baik.
Boleh dok.
Ya, saya share screen.
Saya benarkan ya.
Benarkan ya. Alright.
Syazani tak jawab apa-apa lagi ya.
Okey, nampak skrin saya
Okay.
Yang first sekali stream 5 dengan stream 6 tu. Saya tengok dia punya total flow rate. Dia ada 0.22 lah different. Tapi kilogram per hour. Ada different tak?
So doktor cakap untuk stream 4 dengan stream 5 lah, dia different dia 0.22.
Stream 5 and stream 6. 5 and 6.
Ada perbezaan.
Ya, ada different sikit.
Oh, I think this one different is because based on the decimal round off.
Yes.
Tapi 0.57 dengan 0.35. So ada accumulated ke dalam vektor tu. Dia punya total flow rate.
Ke macam memang betul-betul tak ada apa-apa berlaku.
Dia sebab kami assume 100% conversion. So supposedly all molar flow rate in and out is the same. Maybe dia ada beza in terms of ada side product yang terhasil tapi dalam amount yang sedikit.
Okay, tapi nanti cek balik lah. Next one tu stream 6. You punya weight percent tu bukan 1, 0.99. Cuba tambah.
Oh.
So ada 0.01.
Actually doktor hari tu masa saya actually Excel tu doktor dia pandai berubah value doktor. So
sendiri?
Decimal places.
Decimal places dia.
Okay, tapi Pak Yu guna decimal kan dekat sini. So saya kira based on to decimal lah.
Decimal.
So mungkin ada 0.01% untuk
dalam stream tu ada satu small amount tapi dia tak boleh kira sebab tu decimal places yang kita orang guna dalam PFD tu.
Okay, tapi check balik nanti sebab sini dapat 0.99. Okay, yang next tu alamak, nampak tak ni? Kena move sikit.
Kita.
Yang saya circle merah tu.
Nampak.
Kenapa you nak increase ke 120 degree C sebelum masuk evaporator? Sebab evaporator tu operate kat 130 degree C kan? Kenapa nak increase sebelum masuk? Bayar evaporator lah tu. You pakai biasa punya vessel, dia dah separate kan? Kenapa nak ada heating tu?
Because semasa kita buat research, kita tengok ada satu channel, mereka because the inlet for the evaporator and also the outlet for the evaporator, dia condition tak sama. So yang untuk evaporator ini dia masuk 2 atm dan 120 degree Celsius, tapi dia keluar 1 atm dengan 100 degree Celsius.
Temperature tu.
Actually, doctor, at that temperature, the boiling point for water and formaldehyde is at that temperature. Meaning that kenapa kita orang nak guna 120 tu sebab senang for the formaldehyde and water to evaporate. Sebab dia dah masuk-masuk je, dia dah boiling point dia.
Terus dah evaporate lah.
Sebenarnya evaporate.
Separate formaldehyde and water.
Saya ingat boleh remove saja E100 tu. Tak apalah, you fikir blade lah.
Okay, doktor.
Yang tak necessary nak ada E100. Okay, last kali tu yang tu stream 16. Ini. 16 sebelum dia masuk dryer tu.
Stream 16 masuk crystallizer.
Crystallizer. Dia punya pressure dia 0.6. You punya crystallizer 1 atm.
Yes.
Itu dia dah lepas hantar tu baru perasan silap dekat pressure tu. Sorry.
Alright, okay. Itu je Dr. Zaki.
Okay, Dr. Hashim ada apa nak tanya? Thanks lah Dr. Sarudin.
Tanya satu je dapat. Okay, crystallizer tadi. Okay, dia yang 40 Celsius tu.
Naikkan slide dulu. Okay, Dr. Chip teruskan, sorry.
Okay, crystallizer tu yang masuk 40 Celsius ya? Ke yang keluar 40 Celsius?
Masuk is
Masuk keluar 40 degree C.
Masuk 40, keluar 40
Yes.
Tak ada penurunan temperature. Dia constant.
Tak ada, doktor.
Tak ada.
Bukankah sepatutnya kalau crystallization biasanya dia is a temperature kan, dia sejuk kan, cooling. Memang tak ada. Memang masuk 40, kalau 40 dia boleh jadi crystal kah? Ya, betul. Constant temperature
Yes, doktor.
Are you sure? Tak apalah, itu je. Nanti mungkin boleh tengok kemudian lah kot. Okay.
Dr. Hashim tu je. Okay, thanks Dr. Hashim. Okay, saya nak tanya satu benda yang saya ada banyak soalan ni sebenarnya, tapi sampai satu je. Okay, please dengar betul-betul. Okay, you start your stream here, stream 1, stream 2, stream 3, stream 4 dan dengan 1 ATM. Lepas tu banyak jugalah ada 1 ATM sampailah dekat stream 10 2 ATM. Dengar kan so far?
Dengar.
Okay, dengar. Saya punya soalan ni simple je. Saya nak tanya, 1 ATM yang you record inside your PFD ni adakah sama dengan 1 ATM yang dekat luar? Maksudnya dekat you punya campus, dekat dunia kita ni. Faham tak soalan? Sila jawab. Okey, saya tambah lagi sikit point. 1 ATM adalah temperature yang kita sekarang sedang hidup dengan selesanya sekarang lah. Betul tak?
Yes, we
Maksudnya
should.
kita sekarang ni, you dekat situ, saya dekat sini, yang lain-lain semua dekat rumah masing-masing apa semua tu kan. Kita wujud sekarang dengan keadaan kita sekarang satu ATM. Betul tak? Okay, so dalam pipeline you sekarang ni, satu stream 1, 2, 3 sampai berapa banyak ni, banyak yang 1 ATM ni lah. So is it the same?
From what we discussed, is the same.
Sama. Ah,
Same. Syazani, sama ke?
Sama. Bila
Okay, saya tanya lagi satu soalan Kalau without gravity, kan, tak ada gravity, dengan temperature, dengan pressure 1 ATM, you boleh gerakkan apa-apa fluid tak? You punya caustic ke, you punya apa, water lah, apa semua tu, boleh gerak tak dalam pipeline? Dengar tak?
Dengar.
Dengar. You boleh gerakkan tak? Jadi maksudnya you imagine je, you letak satu air tanpa
Ni kena dekat luar rumah.
dekat luar rumah ke dekat mana kan, you letaklah air dengan satu ATM. Dia boleh gerak tak? Kalau tak ada gravity.
Logically,
terapung.
tak.
Boleh.
Air SAJ yang masuk ke you punya rumah, hostel apa semua tu kan, syarikat air Johor. Macam mana dia boleh sampai dari air tu, the water, how can it reach our home, our storage tank punya water tu? Berapa agaknya pressure dia?
Pumping system.
oh, dia akan pump.
Berapa? Jendang tak dengar? JL.
Using the pumping system.
Not to say the pumping system. I'm asking about the pressure. The pressure
Pressure
inside
inside
the pipe.
the oh,
Tapi high pressure lah.
High pressure.
Lagi tinggi. Daripada satu itu.
You punya anggaran berapa?
15.
15 apa?
Ya, 15 ATM.
15 ATM. Wow, okay. 15 ATM macam Zani cakap. Yang lain?
Salah.
5.
5. Okay.
Yes.
Ya, Tira, awak dah baca buku saya kan? Awak rasa berapa?
Maybe tak jauh dari satu ATM.
Okay.
Kalau terlampau
Which is lebih kurang?
lebih kurang lah.
Yelah, lebih kurang berapa kalau tak jauh dari satu ATM?
Maybe 5 to 10 or 5 to 4, something like that.
Okay. Saya tanya ni sebab apa ni, yang lain, panel yang lain, kalau saya salah tolong betulkan lah sebab saya rasa lah, saya pun tadi bincang pasal benda ni dengan Dr. Mazura kat rumah ni. Tapi macam kita pun tak bersependapat ataupun yelah ada lain punya pendapat. Tapi I was previously a process engineer dan saya sangat macam particular dengan pressure ni tau. Dengan flow, dengan pressure, dengan temperature ni. So saya rasa kalau macam satu ATM dekat stream 1, stream 2, stream 3, lepas tu 4 ATM, macam mana nak gerak sebenarnya daripada stream ke stream? Dia punya driving force, pressure driving force, how it can move. Itu saya punya concern lah. Jadi mungkin benda ni tak nampak critical ataupun mungkin nampak remeh, tapi actually you need something to push. So whatever, contohnya macam kalau macam caustic dan water dan formaldehyde ke apa you dapat daripada storage tank, definitely kalau tak ada gravity, maksudnya storage tank you bukan kat atas kan, you mesti ada pump. Dan pump itu adalah is creating the pressure for it to move forward. Betul tak?
Betul.
Jadi kalau pressure-nya semua sama, macam saya rasa macam mana dia macam
tak boleh push lah.
dia tak bergerak, nothing is flowing lah, macam semua stagnant. Dia macam block ke ataupun macam tak ada apa-apa terjadi. Sama ada flow ataupun tak ada flow. Itu yang saya komen lah. Jadi mungkin kalau lah katakan pressure tu, sebab saya rasa benda ni mungkin tak pernah dibincangkan secara detail dalam kelas ke apa lah kan. Jadi maksudnya kalau pressure tu mungkin daripada stream 1, 2, 3 tu mungkin besar sikit, dan stream keempat mungkin rendah sikit dan rendah. Lepas tu nanti you ada P100, nampak tak? You punya pressure, pump nombor 100, centrifugal pump kan? P100 tu kan, dia increase balik pressure.
Pump balik.
Dia pump balik. Jadi dekat situ, dekat UPPFD ni, You dah nampak lah, maksudnya bila ada tu terus dia jadi 2 ATM. Jadi dia nampak lah, tapi lepas tu dia 2 ATM, 2 ATM. Lepas tu lama-lama dia 1 ATM. Jadi kat situ dia punya punca pressure gradient tu boleh terhasil. Dan seterusnya. Cuma yang depan-depan tu macam kurang pressure lah.
Okey, faham.
Itu je lah yang saya nak state. Lepas tu lagi satu, C100 in your PFD ni, C100 is actually apa sebenarnya? Turbine ni gunanya untuk
reduce the pressure liquid stream.
Pakai turbine. Saya pun tak
Power
tahu, saya
recovery
tanya je lah.
turbine. Power recovery turbine.
Power recovery turbine. Okay,
Specifically for reducing pressure.
Ni saya tak sure lah, tapi saya tanya sebab saya pun belajar lah daripada opinion ni kan. Okay, nanti saya check lah. Okay, bottom stream 13, we're talking about stream 13 kan. Bottom stream 13, reduce temperature to 40 degrees Celsius and make it vacuum at 0.6. Stream 13 kat mana? Kat situ.
Stream 13 yang in outlet formaldehyde tu.
Okay, outlet formaldehyde. Okay, sorry. So, saya reiterate soalan dia. Outlet formaldehyde tu lepas tu pergi ke mana? Formaldehyde and water.
Yang tu kita discharge sebab daging banyak water.
Okay.
Yang water lagi.
Tapi untuk part ini kita still thinking nak recycle tak, because dia kalau kita recycle dia ni, because water evaporated dia memang banyak. So kalau nak recycle kita kena remove water dulu. Remove sebahagian water dulu, dan baru tarik ke stream yang ada formaldehyde. So still thinking lah, dia unit operation punya cost high tak, because dia formaldehyde dan water macam binary mixture lah.
Okay, alright.
So dia
water lagi banyak.
So dia thinking nak guna unit operation apa untuk buat recycle lah. Tengok dia cost dia tinggi tak.
Okay, last question. Dalam UP process description, you mentioned stream 4 and stream 7 heated by E100 and E101. Okay, stream 4 and stream 7 heated by E100 and E101. You mentioned the heating source is boiler. Okay, this is for your future lah. Maksudnya I think it's better not to use boiler because you have other streams that is hotter than the other streams. So you use the stream nanti bila you buat apa tu
heat integration.
Heat integration tu nanti you jangan pakai boiler lah. Sebab macam jadi sebab benda tu macam contradict lah. Jadi bila you buat integration you pakai stream yang lagi panas lah. Itu je lah.
Okay, boleh.
Okay, itu je lah daripada saya. Okay, Dr. Nur Rashikin, Dr. Sarudin, Dr. Hashim, ada apa-apa lagi? Baik.
Okay, tak ada.
Okay, tak ada. Okay, kalau tak ada, okay, thank you very much.
Lagi.
Apa dia?
Ada sikit lagi.
Okay, apa dia?
Untuk PFD ni, saya rasa you kena rearrangekan you PFD you ni bagi dia apa orang kata ni lah you nampak you punya arrangement of PhD ni PhD ni untuk yang stream 20. 1/3 of tu adalah stream 20 dengan apa 21 dengan 22. Sedangkan itu just simple. You nak cantikkan stream, sedangkan stream yang lain tu you compress bagai ganara, and then the third yang akhir tu you pusing stream apa 20 tu sampai jadi 1/3 of your figure tu. Itu apa benda? You nak cantikkan figure you ke? Okay.
Okay, faham. Okay, faham tak korang?
Okay.
Okay, rasanya tak payah buat macam ni kan. Rasanya pendekkan lepas stream 20 tu pendek, lepas tu dia terus ke kiri je lah. Turun bawah, lepas ke kiri dah cukup. Ataupun mungkin takut pandai-pandailah you
buat YouTube ni.
Pandai-pandailah you buat
Ujung sana, lepas tu patah balik.
Okay, faham.
Okay lah. So thank you very much team 6. Okay, you can please leave now. Nanti kita panel discuss sikit. Okay, 1, 2, 3, 4 semua leave.
Okay,
Okay.
doktor.
Terima kasih.
Okay,
Thank you.
welcome.
Thank you.
Yes, doktor.
Thank you,
Okay,
doktor.
thank you, thank you.
Macam mana nak lift
Leave je, leave. Okay, Dr. Nora Shikin, Dr. Sarudin, Dr. Hashim, sementara kita tunggu tim nombor 7 masuk. Mungkin kita ambil masa untuk isi dululah kot markah-markah kot. Tadi takut terlupa. Isi markah dengan isi comments. Comments tu pun kena isi juga.
Nanti markah tu mesti dekat Excel lah.
Saya bagi evaluation form,
Yang
interim
Excel
presentation.
nanti
Boleh
bila
isi.
kan?
Isi dalam tu terus lah.
Nanti itu bagi lepas ni boleh?
Boleh.
Lepas
Bukan
ni lah
tak
kat sini kan?
boleh
Okey,
bagi
okey.
kemudian. Cuma takut kok kalau macam nak isi meja komen dulu ke apa kan.
Tadi live putus sekejap tadi. Syarazi tu tadi dia ada jawab kan?
Dia ada jawab. Dia tak banyak sangat jawab tapi ada jawab sikit-sikit lah.
Sebab tadi line putus sekejap tadi tak perasan sangat dia punya tu. Okey. Okay.
So jadi sekarang ni saya invite tim nombor 7 masuk lah
Okay.
Okay, saya invite tim nombor 7 masuk. Okay, sementara tu boleh, kalau siapa yang free bolehlah isi apa-apa yang patut. Saya pun tengah isi juga. Dr. Hashim, ada kat situ tak?
Ada. Tengah isi borang sekejap.
Ni CTPS tak bagi lagi kan?
Dah hantar dah. Tak dapat dah?
Rasa macam tak dapat
Dah hantar.
lagi. Dalam email?
Tak dapat lagi. Email.
Okey, nanti saya
Tapi nanti saya boleh.
okey.
Kalau tak ada saya resend lah. Okey
Okey. Okay, tim 7 kejap siapa yang dah masuk? Okey, Fitri pula, Dania. Seorang lagi belum masuk.
Chan dah masuk dah.
Okey, Chan dah masuk. Okey, upload your slides please. Okey, dah upload slide kan? Okey, siapa yang akan control slide?
Saya.
Fitri kan? Okey, Fitri control slide. Okey, saya buka majlis dulu. Okey. Assalamualaikum and good afternoon semua. Okay, ini tim 7 sekarang. Tim 7 disupervisekan oleh Dr. Hanafi Mat. Okay, dengan you all sekarang kita ada panel kita Profesor Madya, Dr. Nora Shikin Osman, Dr. Hashim Hassan, Dr. Sahrudin Harun dan saya sendirilah. Okay, kita bagi you masa 20 minit. So kalau katakan kita start pukul 3.20, 3.40 you stop lah Boleh?
Boleh.
Okay, cuba buat sound check dulu. Okay, Fitri cuba cakap.
Assalamualaikum.
Okay, dah dengar. Okay, lip sync. Your voice.
Hello.
Okay, pula.
Hello.
Okay, dah dengar.
Hello, testing.
Okay, Dania
Hello.
Okay, alright, dah dengar.
Hello.
Okay, so lepas 20 minit saya akan stopkan you. Kalau adjust tambah campur tolak 1 minit, 2 minit tak apalah. Kalau ada masalah interruption, internet dan sebagainya lah tapi kalau boleh you stop in 20 minutes. I will give reminder dekat chat. Okay, so boleh start lah sekarang.
Okay. Assalamualaikum and very good afternoon to the trainers. So today we are from Group 7 and want to present about our production of 20 metric tons annually of Pentaerythritol. So before we roughly explain about our chemical product background. So firstly is the application of Pentaerythritol. So it is usually used for cosmetic as a resin, chelating resin, varnishes, PVC stabilizer, and high oil ester. So next, this is the physical and chemical properties of our product, which it is in a white and crystalline powder. The boiling point is 276 degree at 4 kilopascal. and the melting point is at 260.5 degree. So next I will proceed. I will give to Dania to proceed.
So next, I will explain on the market survey. So as you can see on the pie chart, Asia Pacific is the leading regional market and account for 42.5% of total volume. And China is the major producer as well as the largest consumer for pentaerythritol. But the demand of pentaerythritol in Malaysia is unknown due to lack of resource. Next. Next. So for the supplier and competitor of pentaerythritol, as we can see from the table, Celanese from US will be Chang Chemical from China, and also Perstop is the major company that produce pentaerythritol. So the competition for Malaysia to produce pentaerythritol is less due to there are no production of pentaerythritol in neighboring countries such as Indonesia, Thailand, and also Singapore. Next. So for the market supply and demand, the price per metric ton for pentaerythritol since 2019 to 2020 remain constant at 1,300 US dollar. And the demand of pentaerythritol in Asia Pacific 2006 is 142,410 tons per year. And the supply in Asia Pacific for 2006 is 192,600 tons per year, and it is expected to grow at 8.1% per year to 2013, particularly in growth countries. Next. So for the capacity of production, we have calculated using the CAGR of 4.25% per year of supply from 2006 to 2020. And after calculating the difference of supply and demand, we get the capacity to produce pentaerythritol for about 20,000 tons per year. Next. And for the process selection, we have choose 4 reactions. If for the first reaction is the reaction of formaldehyde and acetaldehyde, this process involves reacting 4 moles of formaldehyde and 1 mole of acetaldehyde to produce pentaerythritol, and the economic potential is 0.331 US dollar per pound pentaerythritol. Next. So this is the technical details and also the disadvantages of reaction 1. Next. So the second reaction is the synthesis of formaldehyde from catalytic oxidation of methanol, followed by reaction with acetaldehyde. And this reaction is actually similar to reaction 1, but the formaldehyde is synthesized by catalytic oxidation of methanol by the plant. So the economic potential is 0.419 US dollar per pound pentaerythritol. Next. So this is the technical details, operating condition, and also the disadvantages, which is actually quite similar to the reaction 1, except that it is exposed to methanol. Next. So the third reaction is the synthesis of acetaldehyde from catalytic oxidation of ethylene, followed by reaction with formaldehyde. This reaction is also similar to reaction 1, but the acetaldehyde is synthesized by catalytic oxidation, or also known as Waker process, and the economic potential is 0.448 US dollar per pound pentaerythritol. So this is the operating condition and also the disadvantages, which is also quite similar for the first reaction, but it is exposed to ethylene. Next. So the fourth reaction is the synthesis of both formaldehyde and also acetaldehyde reaction. And this reaction is actually the combination of reaction 2 and reaction 3. And the economic potential is 0.407 US dollar per pound pentaerythritol. And this is the technical details and also the technical details and also the disadvantages of reaction 4. Next. So next I will explain the process screening. So after we have done process screening for process 1, 2, 3 and 4, we have decided to choose process 1 because it has the highest score to be compared to process 2, 3 and also process 4. Next. Okay, for the site selection, we have choose 3 locations, which is the Kertih Industrial Estate in Terengganu, Taman Laju Industrial Park in Sarawak, and also Gebeng Industrial Area in Pahang. So for the site selection, we have choose Sarawak to build our plant. It is because the area availability in Sarawak is higher to be compared with the other two, and also the land price is also much cheaper. And we can also get the raw material supply in Sarawak itself to be compared with the other two that we need to import. And it is also nearest to the town, and it has a lot of facilities and infrastructure. Next. And for the water supply, it has intermediate price, and for electrical supply, it is also the cheapest to be compared with Pahang and also Kertih. And you can also get a lot of human resource in Sarawak.
Okay,
So next I will pass to Chan for process synthesis. Thank you.
Okay, I am Chan Lip Ching and I will explain on the process synthesis of pentaerythritol. Next. The first step is to do process selection, which was explained by Dania just now. However, the overall reactions in chapter 1 were not complete because the reaction did not take account into the side reaction of sodium hydroxide and formic acid. But this does not affect the ranking of economic potential because every reaction involves this side reaction. Next. As you can see, these are the reactions involved in the production of pentaerythritol, such as main reaction, undesired side reaction, and side reaction. The overall reaction is stated at below. Next. This is the updated economic potential after including the reaction of sodium hydroxide and formic acid, and we got 0.233 USD per pound of pentaerythritol. Next. Step 2 is to determine the amount of feed stream and recycle stream. With the assumption of 330 days operation and 24 hours per day, the production capacity is about 2525 kg per hour. Based on the literature review, the specification of reaction are stated as below and in the process description, with the overall yield of 93.05% for pentaerythritol based on acetaldehyde. Next. Next. Okay, to obtain the specification stated, 11 mole of formaldehyde, 1 mole of acetaldehyde, 1.1715 mole of sodium hydroxide must be fed into the reactor. Water is in excess while acetaldehyde is a limiting reactant. The required amount of acetaldehyde is 19.944 kilomole per hour, which is rounded off to 20 kilomole per hour of acetaldehyde in case there is no complete separation of pentaerythritol. This is the basis for our process synthesis. After the neutralization reactor, the distillation column is used to separate 99% of formaldehyde, 53% of water, and 1% of pentaerythritol. 100% of formaldehyde and water are separated using dryer and recycled back to the reactor. Next. Step 3 is to separate the components from the reactor. Separation system is designed based on the literature review and the physical properties of components. Next. Okay, this table shows the physical properties of components involved in our process. Next. This is the conventional method used in the separation system. Since pentaerythritol, dipenta, and tripenta are insoluble in cold water, All of them crystallize at low temperature, and centrifugal filter is used to separate the solid and liquid phase. Next. Okay. This is the conventional process flow sheet for penta-erythritol production. After the reactors, distillation column is used to recover the excess formaldehyde. Evaporator is used to remove the remaining formaldehyde in the streams, and dryers are used to obtain the dry products. Next. Our group did some innovation to separate dipentyl and tripentyl from penta-erythritol to obtain higher purity of product compared to the conventional process. We introduced flash distillation column before crystallizer to separate water, penta-erythritol, and sodium formate as vapor. The reason we introduced flash distillation column is due to the large boiling point difference between the sodium formate and dipentyl-erythritol, which is up to 300 degrees Celsius. Next. Okay, this is the process flow sheet after innovation. After the first evaporator, flash distillation column is used to remove dipentyl and tripentyl-erythritol, followed by the second evaporator to remove some water for the crystallization process. Next. Step 4 is to do temperature, pressure, and phase change for the process flow sheet. Next. This is the process flow sheet after doing step 4. Next. Step 5 is the test integration. Catalytic reactor and CSTR are used to carry out all the reactions. Ordinary distillation column and flash distillation column. Next. Evaporator and dryer are used for the separation purpose for the differences in volatility. Crystallizer and centrifugal filter are used for the separation based on the differences of solubility in water. Pump, expander, heater, and cooler are used for the temperature, pressure, and phase change. Next. Okay, next. This is the manual PFD for our penta-erythritol production. Next. Okay, these are the heuristics used in the process synthesis, such as heuristic 2, where excess formaldehyde is used to completely consume acetaldehyde, and heuristic 5 is to recycle the unreacted formaldehyde. Next.
Okay, so moving on to manual calculation of mass and energy balance. Next. So we are using basis of 20 kilomole per hour of acetaldehyde. Okay, so considering the fact that our plant operates for 330 days per year, 24 hours per day, so we assume that the system is at steady state, no leakages in pipes and vessels of the system, and the total input of any substance into a pump, valve, mixer, or heat exchanger is equal to the total output. Next. So for the first unit operation, we have 3 input into the mixer and 1 output. All right. Okay, and the mass balance is correct. And for catalytic reactor, this is where the reaction between acetaldehyde and formaldehyde occurs. As you can see, there are 2 inlets and also 1 outlet. Stream 7 is a fresh feed of sodium hydroxide solution which acts as a catalyst for the reaction. Okay, and the mass flow rates for each component in stream 8 depends on percentage of conversion and also percentage yield. Next. For neutralization reactor, it is used to neutralize the excess sodium hydroxide with formic acid. So the conversion of formic acid is 100%. Next. At the distillation column, 99% of formaldehyde is extracted to be recycled to the mixer. Next. At the dryer, DR100, 100% of separation of formaldehyde and water is achieved from pentaerythritol. Next. For evaporator EV100, 100% separation of formaldehyde and 2.29% of water as vapor state is separated. Next. For flash distillation column D101, 100% separation of water, pentaerythritol and sodium formate from dipenta and also tripenta. Next. For evaporator EV101, 41.75% of water is separated as vapor state. Next. Next. Okay. At the second, which filter is only 87%. So that's the reason we have 13% moisture content in our solid stream, which is stream 44. Next. At dryer DR101, we have 100% separation of water to dry the sodium formate. Next. At dryer DR102, we have also 100% separation of water as vapor state to dry the solid pentaerythritol. Next. So these are the specifications used for the energy balance calculation. So basically, we are using 25 degrees Celsius and 1 atm as our reference state. And the equation highlighted in red we use to calculate enthalpy for each stream. Next. So these are the values for the heat capacity coefficients. We got the values from two sources, Paris Chemical Engineers Handbook and also Felder's Elementary Principle of Chemical Processes. Next. So this is the an example of how energy balance was calculated. So the total enthalpy is basically the summation of product between molar flow rate and also heat of formation for each component. Okay, now I pass to Fitri.
Okay, I will continue. So this is the simulation of mass and energy balance. Okay, so we are using S1 Plus for our simulation, and the simulation is converging. So this is the comparison of mass and mass balance for manual calculation and simulated calculation. As you can see, there are two streams that have error that more than 50%, which is 17 and 18. This is due to the difference in manual calculation, because in manual calculation we do assumption for 1% of the overhead product, where in the S1 is set for 3.22% for energy balance. So it also have a same error at the 17 and 18, and also the 33 stream. Justification for this stream is the stream for 17 and 18 have the same because of the mass balance error in the mass balance, it affect the energy balance. And for the stream 33, the error up to 20% because they are different on the base state in manual calculation and simulation. So as the conclusion, the production of pentaerythritol is at 2,000 metric ton annually. The Samalaju Industrial Park is chosen as the site of the project. We choose the formaldehyde and acetaldehyde based process, which is the commercial process for the process selection. And lastly, the percentage error that greater than 50% only occur at 3 streams. So that's all. Thank you.
Okay, thank you very much. Can you hear me? Hello, can you hear me?
Yes.
Okay, thank you very much, Team 7.
Yes.
On time. Okay, good. Dr. Norshiki dah masuk belum? Hello. Okay, tak ada. Din, Dr. Sarudin nak tanya tak?
Okey, saya tanya terus ke PDF lah. Lain semua nampak okey. PFD. PDF lah. Yang lain-lain semua okey. Sama macam dulu tadi. Saya nak show saya punya PDF. Ada tadi.
Halo?
Oh ya, sekejap. Okay. So ni saya dah tulis sikit. First yang dekat you punya stream berapa ni? 13 eh?
7.
Ya, 13.
Stream 13.
Stream 13 sampai 16. Pelik sikit kenapa you nak daripada 79 and then reduce to 30 and then back balik to 96 degrees Celsius. Kenapa tak
Okay.
sekali saja?
I answer sekarang.
Ya, okay.
The reason I cool down first, then I increase back. Sebab kalau if panels you all see at the H102, this is actually the energy source for the dryer. So that is the reason I want to cool down the temperature to prevent phase change. I want to avoid the presence of vapor phase in the stream. If there are the presence of vapor phase in the liquid stream, the transport of the mixture will not be efficient. That's why I want to cool down first to make it all to liquid phase. Then after I reduce the pressure, then I increase the temperature for the separation process. Does my answer? Hello?
Yeah, but the stream 16
Sheldon.
Yeah.
Ada Sheldon dah ni tanya yang stream tu. Ni nak tanya tanya part tu juga D100 tu actually apa? What type equipment D100?
Oh, dryer.
Dryer.
D100 is dryer?
DR100 dryer.
No, D100. Yang ni outlet dia stream.
Distillation
column.
Distillation column.
Distillation. What type of distillation column?
Ordinary distillation column.
Top product dia liquid.
Ordinary
distillation column.
Apa maksud ordinary distillation column?
Distillation column yang normal.
Apa you punya top product is liquid and then your bottom also liquid and then you punya temperature your distillation operate at what pressure and temperature?
85 degrees Celsius and 3 atm.
3 atm. So your top product? In liquid
product. Yes, liquid because we have a condenser. We use condenser. Yeah, that's why we will have liquid phase.
Okay. Mungkin figure you tu mungkin tak
betul sangat.
Ni lah, you suppose to ordinary you kena ada compressors tu lah sebab you kata you ada liquid kan?
Betul.
You is a liquid form.
Yes, because we have condenser.
Mana ada condenser? Ada.
Kita tak letak.
Bila you condense, so you still hot liquid.
Yes. The overhead product is liquid phase. Hello?
Okay. So tapi saya tak puas hati lah dengan you punya figure tu, dengan you punya sistem tu sebab you punya feed temperature you berapa?
Feed 25 degrees Celsius.
25 degree Celsius.
Yes.
And 1 atm.
1 atm.
You check balik you punya you punya tu.
Okay.
Sebab you masuk UH and then you punya operate at 3 atm.
3 atm, yes.
ATM and then you come out with a liquid form at what atm? 3 atm.
Overhead product.
Overhead product you.
2.9 atm.
After condensation.
Yes.
So make sure ada you punya flow diagram tu biar betul lah.
Okay. Thank you.
Chan.
Yes.
Nak tanya lagi yang tadi you kata nak avoid phase change kan? So you
Not avoid.
you reduce 79 to 30 and then back to 96. Tapi kenapa apa problem dengan phase change?
Sebab if I tak cool down temperature, masa I reduce the pressure, then phase change will occur.
Yeah, what any problem kan?
Sebab I nak phase change kat heater and dryer saja.
Yalah, kalau ada phase change masa you drop pressure, any problem?
That means I don't have to use dryer to separate the volatile components. Because I want to use dryer, that's why I want to prevent phase change in the early of the process.
Kalau ada phase change, you tak boleh guna dryer.
Sebab from our understanding, dryer we use heat to heat the components, and phase change occurs, the volatile components will evaporate. That's from our understanding.
Ya ke?
Iya ke? Betul juga.
Baiklah, next move pada next part, sama juga.
Okay.
Yang bawah tu.
Okay.
Sebelum you pergi ke evaporator.
Okay.
Right? Sama juga, you 136.
Sama. Concept dia sama. We'll have the same. I will have the same justification to prevent phase change.
You really need kena buat benda macam ni. Okay, tak sure.
You boleh komen?
Ya.
Punya PFD ni just macam you like suka-suka you je nak letak semua equipment
But we
you
have
turun naik pressure, you turun naik pressure, temperature.
From our understanding, we have high pressure in the beginning of the process, then we slowly reduce the pressure to 1 atm. Hello?
Okay.
Dan yang I suka rap tu.
Pening tengok you punya PFD ni.
Mungkin dia banyak equipment lah.
PFD ni sangat complicated. Tu yang macam
Okay.
Okay, Chan, before you masuk dalam evaporator. Before you masuk evaporator, you memang dah ada 22 degrees Celsius.
Yes.
Why you need to increase to 122 degrees Celsius before masuk evaporator?
Because I want to reduce the pressure first. Because from 3.1 atm, I reduce to 2 atm. Then the bubble point or the boiling point of the components will change.
Then kalau auto expander you terus masuk evaporator tak boleh?
Tak, sebab lepas expander 50 degrees Celsius. Dia tak ada.
You apa? You dah salah konsep ni. Siapa nama Chan You dah salah konsep of evaporator. Evaporator, kita dah ada heating coil kat dalam tu. So if you want to heat, okay.
Because from our understanding,
supply heat inside the evaporator. You know you set what temperature and pressure you want evaporator you to run.
Okay, because based from our understanding, we want to do temperature change, pressure change, and phase change for the whole process. Like evaporator, they operate at 122 degrees Celsius. Then that's why we want to heat until 122 degrees Celsius as the energy source for the evaporator. That's from our understanding.
You're gonna check back your understanding lah.
Mungkin ni salah understanding tu. Okay? Baiklah. Okay, lagi.
Yang lain semua sama juga lah. Yang lain semua sama juga.
Sama lah
Yang lain.
betul benda tu Syarudin.
Semua yang I circle semua sama lah.
Tak habis kau nanya kan
Hello?
nanti.
Okay. Next. Okay, saya finish.
Okay. So saya satu je saya nak tambah lagi yang pada Dr. Syarudin dah tanya tu dah cukup banyak dah in term of fundamental concept yang you kena justify balik. And then D101 tu apa dia? Itu
Fitri masukkan balik PFD.
guna apa?
PFD.
D101.
Oh,
Share.
Itu apa?
Flash distillation column.
Oh, D101 flash distillation column.
Problem now.
Hello?
Yeah, we are here. We are thinking.
Oh.
Okay, siapa nak tanya lagi ni sekarang? Dr. Ashikin tengah tanya.
Okey lah, sebab saya pun pening juga dengan diagram ni. Ya.
Dr. Hashim, silakan.
Tak ada apa, saya ingat punya view yang sama lah dengan kawan-kawan tadi yang tanya tadi. Agak kompleks juga untuk tengok pening kepala ni kan. Okey, tu aku tengok balik lah. Maknanya tak boleh net suka-suka.
Susun balik lah.
Ya.
Susun balik.
Okay.
I have question.
Yes.
I have read your mass balance dengan energy balance. Still ada decimal point yang tak berapa konsisten. I hope you can check that. Okay, that's one thing.
Okay.
And then from the next one is your stream 7 and stream 6. Mana Stream 7, stream 6.
Doktor tak clear pula doktor. Saya tak dengar.
Tak dengar? Okay, dengar tak? Can you hear me?
I dengar.
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 Okay, stream 6 dan stream 7. Saya check. Dia macam ada beza temperature dia. 25 dekat stream 6. Lepas tu 25.5 dekat stream 7. Maksudnya selepas daripada pump. Dengar tak?
Dengar.
Okay, boleh.
Kenapa tu
Sebab we assume that there is frictional force that will increase the temperature by 0.5 degrees Celsius.
Which I don't think so. Okay, explain. If you want to explain.
Because during the transport of
Orang lain pula.
chemicals. Okay.
Orang lain nanti Chan Lip Sing je dapat markah, yang lain lagi 3 orang lagi kosong nanti.
Okay. Anyone can answer.
Cepat, siapa nak answer?
Jawab pula. Tak dengar soalan tadi doktor. Sekali lagi sebab tadi
Okay, okay, ulang balik chapter pula. Stream 6 25 degree Celsius, stream 7 25.5 degree Celsius. Why? Saya sangat teruja nak tahu. I'm dying to know this one.
Sebab apa dia naik 0.5 degree Celsius ke?
Itulah.
Yang ni based on apa yang saya faham lah kan.
Okay.
Kalau kita pakai compressor ataupun pump, dia supposedly memang temperature change akan berlaku sedikit. Dia memang ada effect untuk temperature change tu.
Okay.
Sebab tu dia ada temperature dia mungkin nak naik ke 0.5 macam tu.
Okay. Pasal tu lah.
Frictional force tu maybe akan increase the temperature. Frictional force tu maybe increase the temperature.
Okay. Boleh saya tanya, you all belajar benda ni daripada subjek mana?
PD.
Chan Lip Sing, you kena
Yes.
ni you jangan cakap apa-apa. Daripada mana belajar ni? Pula tak boleh jawab ke?
Just assumption je kot.
Assumption? Tak, dia betul-betul ada tulisan dalam buku teks ke apa ke? I'm just wondering. Saya kan, okay, jawab. Jawab. Tak ada siapa boleh jawab.
Saya rasa
Okay lah, tak ada
tak jawab ke? Tak dengar.
Who's answering? Nobody is answering?
Hello.
Pula, cepat jawab.
Hello.
Hello?
Hello.
Okay. Saya rasa buku teks memang dia justify dia same temperature yang keluar masuk pump semua tu.
Oh, okay.
Sepatutnya sama lah.
Buku teks mana?
Tak, bukan. Sepatutnya keluar masuk keluar tu sama. Sepatutnya lah.
Sepatutnya.
Ya. Tapi
Pressure yang
mungkin
lain.
mungkin ada
sebab satu lagi efficiency pump tu bukannya 100%.
Pressure tu akan berubah sikit.
Okay, tak apa, saya dah dengar you punya jawapan. Bagi saya benda tu insignificant lah. Okay. Bagi saya lah. Saya pun dah jaga satu plant yang besar sangat. Saya banyak juga tengok temperature ni macam tak ada beza sangat lah. Maksudnya kalau nak buat PFD ni macam not really significant lah. You can assume the same lah. So, itu yang saya punya pendapat lah. Tapi tak tahulah kalau pendapat saya tak betul ke apa kan. Mungkin panel lain boleh komen ke apa lah. Anyway, itu je lah aku nak tanya. Panel lain ada apa-apa lagi nak tanya tak?
Tak ada.
Tak ada
Okey.
Yep.
Ada satu nak tanya.
Okay,
Nak
silakan.
suruh dia orang check balik flash distillation dia orang. Okay, flash tadi kan ada D01. Actually yang D0 salah satu lah D tu yang flash you. So bila kita flash pada certain pressure and temperature.
Yes.
Kalau you masukkan you punya stream to the flash flash drum tu, you masuk kan ada a certain fixed pressure and temperature, and then you punya outlet stream top and bottom pun same pressure and temperature. Itu bukan flash tau. Kalau you system you operate pada inlet pressure and temperature, ni is liquid vapor separator.
Vapor liquid. Flash drum.
So you jangan claim dia. You nampak you ada two different. Yang you guna satu flash, yang ada yang supposed to guna vapor liquid separator je sebenarnya. It's not a flash distillation.
Okay.
Sebab you tengok you punya dekat you punya apa yang summary table you tu. So sebenarnya you not flash everything. You separate vapor naik atas, liquid ke bawah, itu je. It's nothing in the other component. Itu you kena bezakan.
Second, itu D101 That is D101.
Dia D tadi D101 dengan D100. Ada yang salah satunya plus satu space separator je.
Phase separator. Okay. That is 101 kot rasanya.
Betul. Separator yang mana? Bukan flash.
Okay. Alright.
Okay, nanti check balik lah.
Okay, team 7, okay, take note of the comments. Later we will give you the comments lah, the written comments lah. Okay. Itu sahajalah for now. Thank you very much. Boleh keluar daripada sini.
Okay. Thank you so much.
Thank you.
Okay, panel-panel semua, saya akan panggil tim 8 masuk. Sementara tu kalau ada apa-apa korang nak isi markah ke apa, sementara tunggu dia orang masuk tu boleh lah.
Okay.
Macam mana pengalaman buat interim presentation macam ni? Okay tak?
Okay juga.
Okay juga Lain lah feel dia kan. Tapi okay lah, kita buat lah apa yang patut. Dah suruh dah dia orang masuk, kejap lagi dia orang masuk lah sikit-sikit ni. Okey, tim 8. Sarah ni nama betul ke? Tim 8. Tu Haslina kan? Hello. Tak dengar Haslina. Jai dan
Lagi saya.
Soteng.
Doktor sekejap ni saya tukar akaun kejap. Salah akaun lagi.
Tak apa. Kalau dah ada ni biar. Maksudnya
Okey je.
nama awak bukan Sarah Christina tapi nama awak adalah Haslina.
Ya saya.
Okey, Haslina ada, Lin Jai ada, Soteng ada, Najib ada. Okey, panel yang nama user ni sebenarnya nama dia bukan user tau. Nama sebenar dia Najib. Dia tak register betul-betul. Yang Sarah Christina pula nama sebenarnya Haslina. Okay, good afternoon guys. We are going to start shortly. Okay, let me just give you brief information about our program now. We have here with you guys the panels, which is Associate Professor Dr. Nur Rashiki Osman, Dr. Sahrudin, Dr. Hashim, dan saya sendirilah. Okay, kita akan bagi masa 20 minit. So tadi kumpulan 6 dan kumpulan 7 berjaya siapkan dalam masa 20 minit, which is very good. So we hope that your team can also finish on time. Yang membuatkan masa lama tu because sesi soal jawab lah antara panel dengan team masing-masing tu lah. Okay, so I will give you the reminder of the remaining time dekat chat box, so that please stay alert dekat situ. Okay, panel ini kumpulan 8 ni diselia oleh Dr. Muhammad Kamarudin Abdul Hamid. Okay, so student Kamal lah ni. So, okay lah, sekarang pukul 4.3 minit. So, upload slide sekarang. Siapa yang jaga slide?
Okay, saya Soteng.
Soteng, you jaga slide. Okay, letak slide dulu. Okay. Now is 4:04. I assume we start at 4:05 lah. Okay, so are you ready? Sound check sekarang. Semua suara okay tak? Najib
Okay.
cakap. Testing.
Hello.
Tak berapa clear lah Najib.
Okay, boleh dengar.
Najib tak berapa clear. Haslina? Testing.
Testing. Dengar tak?
Okay. Dengar. Jai?
Dengar.
Hello?
Dengar. Okay. Soteng, okay. Suara.
Testing.
Okay.
Testing.
Okay. Soteng.
Dengar tak?
Okay, dengar. Najib tu tak berapa clear tu. Tapi kena cakap kuat sikit Najib. Itu dengar sikit. Dengar. Okay, boleh start. Okay, boleh start. Silakan. So nanti habis pukul 4.25
Good afternoon to all the panels. We are from team 8. Now we are going to present our plant design project on production of 20,000 metric ton annually pentaerythritol. Along our presentation, we will pronounce pentaerythritol as PE. Okay, now I will pass to Haslina.
Okay, I will start with chemical product background. So PE is an odorless white crystalline and solid compound which is contain 5 carbon atom, 12 hydrogen atom and 14 oxygen atom. So it is soluble in water, methanol, ethanol, glycerol, ethylene glycol, formamide, and it is insoluble in acetone, benzene, paraffin, ether, and CCl4. So basically, PE is stable under normal temperature and pressure, and this component is capable of creating a dust explosion, and it may emit toxic fume under the fire condition. And PE can cause nausea, dizziness, headache, eye and skin irritation, and also it can cause respiratory and digestive tract irritation. So next slide. Okay, so we move to application of PE. So we can see worldwide that 37% is used in alkyne paint, followed by alkyne ink, alkyne adhesive, plasticizer, varnish, radiation cure, coating, lubricant, and explosive. Next. So I will move to market survey. So according to Global Pentaerythritol Market Research released by Grandview Research on 2015, the global market demand is expected to reach 781,000 metric ton in 2020. So from the bar chart, we can clearly see that the application are divided into several categories, and we can see that paint industries occupied the largest percentage. Next. So in 2013, the global PE market spanned over 5 regions, which is Latin America, North America, Asia Pacific, Europe, and Middle East and Africa. Asia Pacific was the leading regional market and accounted for around 42.5% of total in 2013, which is around 23,000 metric ton per annum. And Asian Pacific is also expected to witness the higher growth rate of 5.9% from 2014 to 2020. Therefore, in 2020, Asia Pacific is estimated to reach around 378,000 metric ton per annum, which is around 48.4% of global demand. Okay, next. Okay, from the table, we can see that Malaysia demand towards PE in 2018 is 7,000 metric ton per annum. Next. So this slide show our supplier for our raw material, which is formaldehyde, acetaldehyde, and sodium hydroxide. Okay, next. And this slide shows some chemical companies that produce PE, which is in India and China. So according to eChemie price analysis, so the market price of PE in 2019 is $1,350 per metric ton, and the market price was dropped to $1,300 per metric ton in 2020. So for the capacity of plant, demand of Malaysia towards PE in 2018 is around 7,000 metric ton per annum, and the PE demands of Malaysia's neighbor countries is around 13,000 metric ton per annum in 2018. So we, Pentachem Engineering Sdn Bhd, suggested to produce 20,000 metric ton per annum, which is 5.3% of the total demands of Asia Pacific. So I will pass to Najib.
For the site selection, we propose 3 different places, which is Demak Industrial Park Kuching in Sarawak, Private Industrial Zone in Pulau Pinang, and also Gebek Industrial Park in Pahang. Next, this is the list of criteria for our site selection, which is the first one is raw material, followed by utilities, land price, marketing area, transport facility, availability of labor, local community consideration, and also politic and strategic consideration. Next, after consider all these criteria, we choose Private Industrial Zone as our plant site because the marketing area is near, which is only 19 kilometers from the Georgetown. We can easily get the raw material supply, which is formalin from the Selangor, NaOH from the Perak, and also acetaldehyde from the China. For the transport facility, we have North-South Expressway, Penang Port, and Penang Airport. Next. Then, Pembadanan Bekalan Air Pulau Pinang can provide us with low tariff water supply for the site, which is only cost for RM1.30 per meter cube water supply. Next. Next. This is the list of, okay, for the land price, it is quite pricey, which is RM65 per square feet. Since there is large population in the Pulau Pinang, the availability of labor is higher. For the effluent disposal, we have Darkot Industrial Water Sdn Bhd and also Sungai Dua Water Treatment. The climate in Pulau Pinang is tropical zone. And then USM, UiTM, KKTM, and also Seberang Jaya Hospital are considered as local community consideration. For the politic and strategic consideration, we maintain the politic tax initiative. Next. we are moving to the process selection. Here we have three different pathways. The first one, we use the acetaldehyde, formaldehyde, and NaOH as our raw material to produce the PE and also sodium formate. The EP here is 2 ringgit and 96 cents. Next, for the second pathway, we use the calcium hydroxide instead of sodium hydroxide to produce the PE and also calcium formate. Here, the EP here is 3 ringgit and 34 cents. Next. Lastly, we just added the sodium carbonate into the second reaction to convert the byproduct, which is the sodium formate into calcium formate into sodium formate and calcium carbonate. Here, the EP is 2 ringgit and 85 cents. Next. This is the list of advantages of each pathway. The first one, it is easy to remove the sodium ion in the form of sodium formate. It is also known as facile reaction that has high conversion rate. Lastly, the byproduct, which is sodium formate, can be reused in the same for the other purpose. The second and the third one use calcium hydroxide instead of NaOH, which is cheaper than NaOH. Except the second one has high conversion rate compared to the third one. Next. This is the list of disadvantages of each pathway. All of them has the possibilities of the occurrence of side reaction. The second and the third one share the same disadvantages, which is the formation of calcium formate will cause the difficulty in separation process. It is also known as non-facile reaction. Lastly, for the third pathway, it is required of two separate units for the removal of calcium carbonate and sodium formate, which will increase in costing. Next, after considering the EP advantages and disadvantages, we choose the first one because it has high gross profit. Then it also known as reaction that has high conversion rate that can be reached up to 100% conversion. And lastly, the sodium ion can be easily removed. Next.
Okay, now I will explain about the process flow diagram. So this is a reaction that will occur in our reactor. Our reactants will undergo aldol condensation and cross-Cannizzaro reaction. First, but we finalize by using their overall reaction as our main reaction. Which use the formaldehyde, acetaldehyde, and NaOH to produce PE and sodium formate. So the conversion for our main reaction is 100%, and to make sure that it is 100% conversion relative to acetaldehyde, we will feed in excess the formalin and sodium hydroxide. We also assume another side reaction which involving the formaldehyde and sodium hydroxide to produce the sodium formate and methanol. The conversion is 90%, and the side reaction is only take place after the completion of the main reaction. This is our process flow diagram. First, we will mix the formalin, acetaldehyde, and sodium hydroxide in a mixer. We use formalin instead of formaldehyde due to we cannot find a company that produce a pure formaldehyde in the form of vapor or liquid form. In our formalin, it contains 50% of formaldehyde, 12% of methanol, and 38% of water. After the mixing, the mixture is pumped and heat up to 47 degrees Celsius, which the 47 degrees Celsius is our operating condition. Then they will do the reaction is a CSTR. The CSTR is in isothermal. Therefore, we will install a cooling jacket outside the CSTR. After that, the product, byproduct, side product, and the unreacted reactant will pump to 2 atm before entering the first separation unit, which is fresh column. In the process of pumping to 2 atm, the formaldehyde will be vaporized completely. Therefore, in our fresh column, vapor formaldehyde can be removed and then sent to flare. The other liquid mixture are then pumped to the second separation unit, which is the ordinary distillation column. In this distillation column, methanol and water will be removed and cooled down to 25 degrees Celsius and sent to methanol purification plant. The left three components, such as sodium formate, PE, and sodium hydroxide, will then pump and heat up to 485 degrees Celsius. In the condition of 485 degrees Celsius, 485 degrees Celsius at 5 atm, the PE and sodium formate will be vaporized completely. Therefore, they enter the third separation unit, which is fresh column. At here, the liquid sodium hydroxide can be separated out and then sent to wastewater treatment plant. The vapor PE and vapor sodium formate will then condense and cool down to 310 degrees Celsius to make sure they become liquid again before entering the last separation unit, which is ordinary distillation column. In this column, sodium formate and PE will be separate, and both of them are cooled down to 25 degrees Celsius before sent to packaging area. This is our simulation PFD in using Aspen high-seed initial converge. Now I will explain the innovation of the design. From the previous design, we do research in the pattern. They produce a PE in the solid phase. Therefore, some part of their process is in batch mode, since they involve the strategy and solid. So for our design, we innovate produce our product in the liquid phase so that our process can be in continuous mode that only involve the vapor and liquid. The advantage of our design is continuous process can be carrying out, and we can increase the purity of the product, which mean the PE. Since from previous design, when they produce a solid PE, there was some impurity crystals such as sodium formate crystal or sodium hydroxide crystal present together with the product. So if we produce it in the liquid phase, so our purity of product can be increased, since we can avoid some impurity. Now I will pass to Jia.
So now I will present the mass balance and energy balance calculation. In our design, we need to produce 20,000 metatron per year of pentaerythritol. The operating times for our design is 330 days per year with 24 hours. That in our assumption, all of our process are in steady state. The accumulation equal to 0. The stream flow rate in kilomole per hour. No linkage found in piping and water system. Conservation of mass is obeyed. And we assume 100% of separation is covered for distillation column and also the fresh column. Also, the side reaction takes place after the completion of main reaction, which means our side reaction is subsequent to our main reactions. Next, from our previous research, we found that the technical grade pentaerythritol will contain 90% of PE and 10% of di-PE. So based on our calculation, we need 19.65 kilomole per hour of pentaerythritol produced. Next, in order to consume all the acetaldehyde, we need to add excess of formaldehyde and sodium hydroxide into our reactions, which means 6 more of formaldehyde will add into the reaction, and also 2 more of sodium hydroxide will add into the reaction. Our side reaction only 90% of conversions. Next, because of no pure formaldehyde found in the market, so we use formalin as our raw material. It will contain 50% of formaldehyde, 11.4% of methanol, and 38.6% of water. Next, I will briefly go through the mass balance calculation for our equipment, which is the mixer, CXTR, fresh column, and also our distillation column. Here is the summary of our mass balance table. As you can see that all of our mass balance stream is already balanced. Next, for our basics of energy balance, our reference stage is in 25 degrees Celsius and 1 atm. The enthalpy of mixing and solution, and also our potential energy and kinetic energy are negated. and the heat of formation and heat capacity is assumed constant, all of our stream is in steady state condition, all the piping and unit operation are well insulated, which means no heat loss to surrounding, and our boiling point change according to pressure for all the components. Next. From the equation, you can see that we need the data for Cp delta T plus the heat of formation, heat of vaporization, and molar volume times the pressure change. As you can see, for the examples for stream 6 and stream 9, due to the stream 6 operating condition different with the reference stage, we need to calculate Cp delta T and also the Vp. But for the stream 9, formaldehyde is undergo the vaporizations. That means we need to calculate the heat of vaporization. The heat of formation and heat of vaporization are assumed constant. Next. For our comparison between the manual and simulation data, for next, our mass balance, all of our stream is lower than 15% error, but the stream 9 and stream 18 is slightly higher compared to others. Next, for our energy balance, except for our stream 9, all of our stream is less than 15%. Next, so for our justification in our mass balance for the stream 9, some methanol and water fresh out together with the formaldehyde. In stream 18, some pentaerythritol and sodium formate are not fresh out. In our energy balance, this because the exceeding deviation of manual mass balance is linked to our manual energy balance. That's why our stream 9 have over 15% error. And for the assumption of constant heat of formation and vaporization and different value of heat capacity and specific volume used in the simulation and also the manual calculation. Next. Thank you.
Thank you.
Wah, cepatnya. Okay, good. Ada lagi 1 atau 2 minit remaining lagi lah. Okay, excellent presentation. Okay, dipersilakan panel. Dr. Nor Shikin dulu ke? Hello, mana Dr. Nor Shikin? Oh, tak. Oh, ada tak?
Orang lain tak nak lagi ke? Dr. Hashim, Dr. Hashim.
Dr. Hashim dululah.
Okay. Tak, saya nak tengok pasal innovation ni kan. Is it kita change daripada mode dia from batch to continuous, kemudian product from solid to liquid. Is it can be called innovation? Itulah saya agak confused sikit lah. Okay, itu je kot soalan saya. Yes, jawab.
Siapa nak jawab?
Tak ada jawapan ke?
Okay. In our opinion, I think change from the batch mode to the continuous mode is one of our innovations. Since when we discussed in our supervisor, he also agreed that the continuous mode is our innovation. Since because in the previous design, most of the company they produce the product in the solid phase. So now we want to change some things to the design, so we produce a product in the liquid phase.
Okay, itu ke jawapannya?
Okay, that's all my answer.
Okay lah saya kita tak komen lah, kita dengar je. Okay, lain soalan? Okay, tadi Dr. Hashim dah habis tanya. Dr. Sarudin, anything?
Okay, saya nak tanya yang production. You decide 20,000 metric ton kan?
Yes.
What's the main reason you decide 20,000 metric ton? Hello.
Hello.
Okay.
Siapa nak jawab ni?
Ada demand ke?
Siapa nak jawab?
Okay, tadi siapa present yang ni?
Saya.
Okay, Aslina. Okay, jawab.
Okay. Boleh tak dekat previous slide? Slide sebelum.
Sorry, wait. Okay.
Satu lagi. If you can see here, on 2013, the demand is 42.5%, and expected growth is 5.9. So if we sum up, we can get 48.4%, which is from that value we times with 781,000 metric ton to get total of 378,000 metric ton for the demand. But we consider export and import from a neighbor country, since we can see that India and India and China. Next slide.
Your competitor.
Yes, competitor is for the China and India. The average is around 50,000, and so we decide to get 20,000 metric.
You tak overproduce ke?
Sorry?
You tak overproduce ke? Population? The total demand berapa? How many world total demand?
Oh, okay. I continue to answer the third question.
Yeah.
So actually, we found out the demand of Malaysia in 2018 is around. Hello.
Hello, teruskan. Carry on.
Hello.
Carry on.
Okay. Okay. So in year 2000. So in year 2000, the demand of Malaysia towards the PE is around 7,000 metric ton, and then from this table, we found out that our neighbor country like Singapore, Thailand, Philippines, and Indonesia, their demands toward the PE is around 13,000 metric ton. So we plan to produce 20,000, but actually this 20,000 we will maybe half will be Malaysia demand and then half will be export, because for our analysis, after we do the research, we realized that actually in the Asia Pacific, the China is still remain the main exporter for the PE. Therefore, and then the Malaysia after we research, we haven't found Malaysia have produced the PE. So if we start to produce the PE, maybe we can start from the 20,000 metric ton first, since we cannot compete with the China, because China is a main exporter in the Asia Pacific area.
Okay. Site selection. You not compare with other site? You compare with other site?
Yes.
Yes.
But you only present for this Pulau Pinang.
Okay.
Oh, you have 3, right? 3 sites, right?
We have 3.
Yes, 3 sites.
Okay. Boleh pergi PDF tak? PFD.
Oh, PFD. Okay. Okay, boleh.
From your CSTR to the flash column, so you ada pump, right? Stream tak nampak. Stream
7 and 8.
7 and 8.
So 47 degrees C, and then suddenly when after you pump, they drop to 46 point something, right?
This because for the normally pump, it will increase the temperature, but for the stream 8 it decrease because there is the vaporization occur. The vaporization actually is the endothermic reaction, so it will absorb some of the heat, so the temperature will be dropped.
So you assume ke you calculate?
We got calculate, but we cannot get the actual value in simulation.
So
But
you
we know it
assume
will
46
drop.
point something. So you
No, we
assume 46
calculate.
point something. Huh? Hello.
Yeah.
So you not calculate?
Hello. We do calculation.
Okay. No assume, eh?
Yeah, no, assume we do calculation.
Same to stream. Cannot see. After the flash.
Stream 9.
Yeah. There's an increase in temperature, right? Stream 10 to 12.
Stream tu Sheridan, stream 8, 9, 10 tu.
10, 11.
Kan, itu macam phase separator juga. It's not a flash. Sebab you nampak you punya sistem tu semua temperature sama. And you punya dekat you punya summary tu pun you hanya komponen dia masih maintain seperti mana in out dia. Cuma vapor atas, liquid bawah. Itu je, tak ada different in term of pressure dan sebagainya.
Yeah.
Okay, noted. Later we will figure out for the fresh column and the phase.
Lepas tu, kenapa you nak increasekan stream 10 to 11 tu? Kenapa you nak increasekan pressure tu pada same temperature sama kan? And then you nak increasekan pressure before tu for inlet stream for T101 tu.
Because
distillation.
Formaldehyde kan?
What happened to the liquid?
No.
Kalau kita increasekan pressure, same temperature. Apa jadi pada liquid tu?
Because in that pressure, the boiling point for the the boiling point for the component.
So you tengok sini you daripada 2 atm, 5 atm, you increasekan pressure, temperature you sama.
Yes.
So I ask you, what happened to the boiling point of the component dekat stream tu bila pressure dia increase?
Boiling point will change.
Apa jadi kat boiling point dia?
Change. The
The boiling point will increase.
Memanglah change. So apa boiling point dia tu makin kurang ke makin tinggi ke? So
Increase.
Increase.
So you punya ni column pressure you berapa?
Our column pressure is 4 atm.
You check balik lah, saya rasa ada something wrong dekat T101 ni. Sebab you nampak bila you increasekan you punya pressure and then you column temperature, you nampak you come out dengan 4 atm. Meskipun saya tak tahu dari mana keluarnya. Adakah column you operate pada 4 atm?
Yes, 4 atm.
Yes, our column 4 atm. We increase to 5 atm and then our column operate in 4 atm due to there will have a pressure difference, so the liquid can flow inside the distillation column.
Lepas tu top temperature you berapa?
The stream 11.
Saya tanya because of kalau you cold liquid inlet, so in term of you kena consider in term of utilities. Kalau you punya inlet of ni stream 4 tu is a cold liquid, adakah you nak operate pada boiling point system? Inlet stream you pada at T1 tu, itu you kena consider kan lah. You balik check balik lah.
Okay, boleh. Thank you, Doctor.
Ya, stream 11 tu. You ada water semua kan? So at 5 atm dia punya boiling point. Apalah you check balik lah.
Dr. Sherlyn tanya tu, kalau 5 atm, H2O berapa dia punya boiling point? Tu ada check ke benda tu?
Ada. Kita ada check. Tapi the stream 11 we feed it in around 47 degrees Celsius, but the the distillate will come out around 100 something degrees Celsius.
Dia say bila you set 5 atm and a very low temperature, betul kalau saya salah ni, maknanya you inlet you in a cold liquid.
Yeah, full
Kenapa
liquid.
you nak mesti operate pada cold liquid? Cold liquid maknanya you need nanti in term of bila you nak design your punya distillation tadi, in term of dia akan effect in term of number of stages, utilities and so on. Okay?
Okay. We will check back. Thank you, Doctor.
Siapa lagi nak tanya soalan? Sementara tu saya tanya soalan. Dengar tak?
Ya.
Okay, stream 18. Stream 18,
Okay.
you mentioned just now you send to wastewater treatment plant. So maksudnya dia terus buang, is it? Which I think
Yeah.
shouldn't it be recycled? Or what maybe you can explain.
Okay.
Okay.
Actually, we got do the cost analysis and Najib will be answer her question.
Najib, okay, jawab.
If we want to recycle the NaOH, we need extra equipment which is flash column, pump, and the cooler. Because in that stream, it consists of certain percent of PE, right? So it is
PE
not
and sodium
actually 100% NaOH. So and then you need to input into the flash column to remove the PE, and then it need pump and cooler because at that stream the temperature and the pressure is not the same as the feed at the feed condition, which is 1 atm and 22 degrees C. So if I add the extra equipment, it will be cost around 10 million. But if I recycle, I only can save around 300,000.
Okay.
In the
Okay, faham. Okay, can you go back to the PFD just now?
Okay.
Okay, while on the way to the PFD, I want to ask, because comparing your work, your project with the previous projects teams just now, it seems that the temperature that you are using is very high. Contohnya stream 14 dia dah sampai ke temperature 328 macam tu, tinggi sangatlah. Because I am not sure about this, can you just please explain how this can happen?
Because we need to make sure all of our stream is in liquid phase. Because maybe other team they use in solid phase or what? Because all of our stream is in liquid and vapor phase. So we need high temperature to capture that.
Okay, so if this is in a very high temperature such as 328, lepas tu ada yang 484, tinggi sangat lah kan. How are you going to actually heat up this stream using what? How are you going to heat up this stream? Pakai apa Contohnya dekat stream stream 14 kan, dia keluar daripada T101, lepas tu dia dah jadi 328. Adakah dia keluar daripada term T101, dia terus jadi 328, ataupun you ada heat dengan pakai apa-apa atau macam mana?
Kerana inside it already got reboiler, so
Okay, the reboiling is up to how many degrees Celsius? Okay, you try to answer that one first. Okay. Nanti I put inside my comments. So later I will give comment. Boiler temperature. Okay. And then subsequently, from stream 15 to stream 16, the temperature is 3 to 8.5 degrees Celsius, liquid form, and then becoming a mixture. Okay. Passing through H101. The temperature, the stream temperature is 485. It increase again. Increase banyak jugalah, kan? My soalan cepu ubas ni adalah, you heatkan dia H101. How do you heat this until it becomes 485? Using what?
We are using steam.
We're using steam. Okay, what kind of steam?
As I know, there is 3 type of steam, which is medium, that can be heated, and the supercritical steam.
Superheated.
Superheated steam. Yes. The superheated steam can achieve up to 620 degrees C.
Ulang tak dengar, Najib. Cakap lagi sikit, ulang balik.
The superheated steam can be reached up to 620 degrees C.
Okay.
For the superheated.
Okay, so if you assuming that you are going to use this heat exchanger, you use superheated steam to heat from 3 to 8 to 485, kan? Tak apalah, saya akan tanya dekat final soalan nanti, dekat final presentation nanti. But I will ask about the heat exchanger. Okay, because heat exchanger ni macam nak tengok macam mana you design nanti. Because dia akan involve superheated steam, dan sebagainya lah. So, I wonder what will be the the superheated steam temperature for you to get to increase the heat to 485. Lepas tu, mana you nak letak semua temperature yang tinggi-tinggi ni, macam mana bila you buat heat integration, you will be macam takut ada masalah. Because nanti semuanya tinggi-tinggi tau. You faham tak soalan saya? So maybe you will experience a problem when you do the heat integration. Because many of your streams are very hot. And then you tak cukup benda untuk nak sejukkan dia balik. Faham tak? So benda tu perlu difikirkan lah. Sebab saya takutlah macam dia tak berjaya nanti dah buat heat integration ni. Okay, itu je lah soalan saya. Okay, yang lain ada panel, ada soalan-soalan lain ke? Dr. Syikir, Dr. Hashim, Dr. Sarudin, anything?
Rasa tak ada kot sebab nanti final presentation nanti kita orang boleh tanya lagi.
Okay lah. Alright.
Hari ni tak ada.
Okay, so team
untuk final nanti.
Okay, team nanti masa final kita akan pastikan sesi soal jawab 20 minit. Okay. Team 8. Ya.
Dia punya drawing ni macam blur sikit lah. So next time kena clear sikit lah.
Okay. Dengar tu. Team 8. Okay, team 8, you can go out from this WebEx. Okay, I want to talk to the panel first. Okay, before leaving. Okay, team 8, bye-bye.
Okay, thank you, Doctor.
Okay, welcome.
Thank you, Doctor.
Okay, terima kasih panel-panel, Dr. Syikir, Dr. Sarudin, Dr. Hashim. Cuma saya nak tanya sikit lah, kalau perasan tadi dekat team 7 tadi, ada tak diorang cerita pasal innovation? Saya rasa macam tak perasan.
Innovation?
Team 7. Team yang tengah-tengah tadi tu.
Rasa macam ada.
Ada.
Tak ada banyak more detail tu in term of dalam education.
Apa dia? Tak dengar.
Innovation dia tadi, dia banyak cerita dalam equipment. Macam dia letak equipment baru ke proses apa, dia selection of equipment tu. Dalam tu apa dia.
Dalam tu. Dia tak ada macam special subtopik lah. Okay. So ada lah.
Subtopik.
Kalau macam tu ada lah. Okey, itu je kot. Nanti isilah Excel tu yang apa tu evaluation form untuk interim presentation tu. Lepas tu dengan ada tab lagi satu tu major comment. Nanti boleh email ke saya lah. Okey? Ada apa-apa lagi?
Tapi form tu untuk semua tim kan?
Form tu untuk semua team, tapi isi team yang kita perlu isi je lah.
Okey.
Sebab nanti tengok dekat kolom dekat apa ni row yang ada kita punya nama je kan. Saya dah letak nama.
678 ni kan? Yang 678 kan? Tiga group je kan?
Saya buat macam ni lah sebab kalau tidak saya tak readykan untuk semua team lah, leceh pula macam banyak.
Betul.
Saya buat macam ni je lah, senang jadi semua dapat. Okey. So nanti tolong hantar email. Okey, ada apa-apa lagi?
Itu saja.
Tak ada
tak ada apa.
Okey lah. Thank you very much for your cooperation. Terima kasih banyak. Jangan lupa malam ni masak apa?
Tak masak.
Tak masak Okey lah. Kita
Ada so pinggan je ini dia.
Besar pinggan. Okey lah. Tak ada apa-apa dah. Okey, terima kasih banyak. Assalamualaikum.